Hello everyone. Today we are going to explore more about the 7 segment display. So first we will do create project. Next project name 7 segment. So next create file. So file name is 7 segment. Okay. Next here we need to select our board, which board we are using. So that is the XC7S50. So that is here XC7S50 CSGA3241. These boards we are going to use here. Next, finish. Okay. Now select this source, and I have the code, so I will just copy paste here. So let's first understand our code. So as module name is 7 segment, here I am giving 4-digit input, so that's why I have taken 3 down 0, and for input I am taking digit name. So it's MSB is 3 and LSB is 0, and our display is 7-bit, so that's why it's a 6 down 0, and output wire 7 down 0 AN. This is for to activate our which display we are going to use. In our boolean boards there are 8 displays. I will show you. So this is the data sheet of our boolean boards. So see here total 8 displays are present. So to activate each display we need to give some signals. So here as a that AN is used for to activate the display. So here you can see that assign AN equal to 8 tick B 11111110. Here all ones and last digit is 0. It means I am activating last display. So to activate the display we need to give 0, and to deactivate the display we need to give 1. So last digit is 0 means it will last 7 segment display will be on, and other are off. And this output wire DP, this we need to keep it 1, and commit here. Here we are giving digits, means input we are giving. If our input is 0, so means if we are giving 0000, means in a decimal or in a hexadecimal it is 0. So if it is 0, then it will go to display 0. So what is 0? This parameter 0 is equal to 7 tick B 0000001. Means to display 0 we need to give this vector. So 0000001 means all are 0 and last digit is 1. So see here, this is our 7 segment display. To activate each segment we need to give 0, means to activate S0 we need to give 0 here, to activate S1 we need to give 0 here, to activate S2 we need to give 0 here. If it is 1 means it is deactivate. So if we want to display 0, then which means which segment should be which segment should be on. So that is S0, S1, S2, S3, S4, S5 should be on, and S6 should be off. Then it will looks like 0. So for that 0 0 0 0 0 0, and last one we need to keep 1. So that's why I am giving here 0 0 0 0 0 0 1. If we want to show 1, then this, see here 1 for 1 S1 and S2 should be on. So that's why we are giving these all should be off. So 0 to inactivate this S0 we need to give 1 1 0 0 1 1 1 1. So that's why I'm giving here 1 0 0 1 1 1 1. So similarly others. So that's why I have defined some parameters here. So according to the inputs, these cases will be implemented in end case in end module. So this is our code. Now I'm not going for run simulation. So run simulation is for the software implementation. I want to do hardware implementation, that's why I'm going for RTL analysis. Okay. See, now we are going for input output planning. So first, what are our inputs? That is digit we have defined that as an input. So now in our boolean boards, see, these are the inputs which we are using. So here on boolean boards at the bottom side, here some some names are given. So I think it is not visible here, I will show you on the board, but some names are there. I will use that. To use this button, we need to keep this name. To use this button, we need to keep this name. So I will give names here, that is called as a package pin. So for digit 3, I am giving K1. For digit 2, K2. Digit 1, L1. Digit 0, M1. So and these are some input output standards we need to give this. So set according to your boards, which boards you are using. So as I am using boolean board, so it is a 3.3 volt power supply is required, that's why it's a LV-CMOS 33. Similarly other also same 33. So I will set this. Now this input is done. Now to activate the display, I will show you. See, these are the displays. Now in input we are going to give the some inputs which activate this last 7 segment. So according to we need to give the package pin also. So this H3 is for the last display and A8 is for the first display. So I will give accordingly. A8, A8, C7, C4, D5. C7, C4, D5, E4, F3, J4. J4 and last one is H3. So this is also done. Now to display, as we are giving in this side, so we will use these package pins. That's C1 we need to keep at D1. So here, sorry, it is DP. So DP is the last package pin, that is C1. Input output standard is same 33. Now we will set display. So this is done C1. Now from here we will give names D1, H4, B1, D1, H4, B1, D1, H4, B1, C2, D2, J3. and last one is F4. So all constraints are done. Now we need to save this file. 7 segment constant. Okay, now we need to go for synthesis, run synthesis. Okay, see here some running synthesis means it is synthesis is going on. So run synthesis is completed. Now we need to go for run implementation. Okay. Now implementation also completed. Now go for generate bit stream. Okay, we are going step by step. First we need to do simulation. This is software implementation, then RTL analysis, then synthesis, then implementation, then generate bit stream. Then on hardware we need to dump our bit stream file. So these are some steps we need to follow. So bit stream is generation is successfully completed. Now here we need to connect our hardware. So open target auto connect. Before going to this, you should connect your board to your PC. Now here we need to program our device, that is program device, and this is the bitstream file which we generated from our code. Now we are going to dump this program. So our bitstream file is successfully dumped on the board. So see, this is image bit, this is LSB bit, 3210. So as a 4-bit input. So if all are zeros, it will show 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 2, 0, 0, 1, 1, 3, 0, 1, 0, 0, 4, 0, 1, 0, 1, 5, 0, 1, 1, 0, 6, 0, 1, 1, 1, 7, 1, 0, 0, 0, 8, 1, 0, 0, 1, 9, then 1, 0, 1, 0 is 10. 10 means A. Then 1, 0, 1, 1 B. Then 1, 1, 0, 0 C. 1, 1, 0, 1 is D. 1, 1, 1, 0 is E. And 1, 1, 1, 1 is F. So this is the 4-digit display on our 7 segment display.